last class, we have covered the introductory class of chemical thermodynamics. In this topic, we have covered system and definition of the system, types of system, different types of system. Today, we will cover the properties of the system. Properties of the system. System. The property of the system may be macroscopic properties. Macroscopic properties means properties related to the particles of the matter, atoms, molecules. But we are not concerned with macroscopic properties. We are concerned with macroscopic properties. So the macroscopic properties of this system. It means the matter is composed of particles. So the properties relate to the combined effect of the particles of the matter as a whole. So this is called macroscopic property. Suppose pressure of the system means pressure everywhere. Volume of the system, volume everywhere. And temperature everywhere of this system. This is not confined to the microscopic level. It is macroscopic properties. So what is its definition? Definition is a system it is the properties associated. These are the properties. These are the properties. These are the properties associated with the bulk of the matter. Bulk of the matter. So the properties are of two types. One is these microscopic properties are of two types. What are they? Number one, extensive property. Number two, intensive property. One by one we'll know. Intensive property. So first, your extensive property. What is extensive property? These are the property in which value depends upon the size or quantities of the matter in this system. So it is the property in which the value depends upon depends on the size or quantity, depends on size or quantity of matter of the system. Example, your mass depends upon the size or quantity of the matter. Similarly, volume. Similarly, your internal energy, E, B, or mass, M. So these are the extensive property. Second is your intensive property. It is the property, it is that type of property of the system which does not depend upon the size or amount of the matter contained in the system. On the size and amount of matter contained in the system. So these are the extensive property. Example of extensive property, example is your density. Density is one of the property which does not depend upon the mass, size, volume. So this is constant. Temperature, pressure, hardness, specific heat, refractive index. All these things are called intensive properties. Other types are there, various examples are there. Suppose your electromagnetic force, chemical potential also are examples of intensive property. Then we'll go to what is the state of the system. What is the state of the system? A system is at if a system is at a state, wait for a minute. So what is thermodynamic state? Thermodynamic state of the system If a system is at a state, if a system is at a state which is determined by specific values of the specific values of measurable macroscopic properties, measurable macroscopic properties. Then the system is said to be in a particular thermodynamic state. Suppose a system is there, its state is defined or determined by set of macros. Suppose pressure, temperature, volume. Three properties are there. Its state for the set of values of P, pressure, volume, and temperature, the condition of that thermodynamic system is called, it is at a thermodynamic state, particular thermodynamic state. So the thermodynamic state is determined by the set of measurable macroscopic properties. There are several macroscopic properties, but there are minimum limit of macroscopic properties whose values at a time can define the state of the system. If certain minimum macroscopic properties maintain at a fixed value, then automatically other macroscopic properties will be set at fixed value automatically. So we should not take more macroscopic properties define the state. For example, in a gas, suppose this is a gas, inside this there is a gas. It is enclosed by, it is kept in an enclosed enclosure, an enclosed vessel, and its value pressure, it is certain value of P, V, and T. So for these particular value of P and particular value of V and particular value of T, this condition of the system is called, it is at a state of the system, at a particular state of the system. It is at a state of the system. Suppose we can take, to define this, we can state three orthogonal coordinate axes. Suppose if we plot a point in this space, certain value of P, certain value of V, and certain value of T, then this is a point. You can plot a point. So this is called a state point of the system. So this state point of the system, it is at a particular value. It has a particular set of values for pressure, volume, and temperature. So when any one or combinedly all of the minimum macroscopic properties changes, then the state of the thermodynamic system changes. Suppose this is at a state, and When the macroscopic properties are varied, then the state of the system is at this point. So from this point to this point, so this is the state point and this is also a state point. So this is varied by varying the values of the measurable values of the macroscopic properties. Particular case I told here, gave an example of gas enclosed in an enclosed chamber maintained by pressure, volume and temperature. For different set of values of pressure, volume and temperature, the state of the system will be different. So if this set of if the set of values of macroscopic properties change, then the thermodynamic state of the system also changes. I told if one or more at a time varied, then the state of the system also varied. And these factors which bring change in the state of the system are called state variables, or in other words is called state function. Is called state function. So state variable or it is called state function. So what is this? So the measurable macros, it is called, we can write the measurable macroscopic properties, the measurable macroscopic properties which determine the state of the system, this system are called state variables or state function. State variable or state function. In other words, you can understand the factors which determine the state of the system, the factors which determine the state of the system is called macroscopic variables. So these macroscopic properties are the factors to change the state of the thermodynamic system. So this, to specify the state, we can determine the values of thermodynamic variables. So we have to mention, so I have told already, we have to mention the minimum values of macroscopic properties, which is sufficient to determine the state of the system, because the values of the rest of the macroscopic properties automatically are kept fixed or kept constant. If we maintain the minimum of macroscopic properties at constant level, automatically the other macroscopic properties are kept automatically in constant values, at constant values. So the change in the value of the state, this is called also this is called state variables or state functions. So the change in the value of the state function, the change in the value of the state function depends on only depends on only the initial and final state of the system, no other factors. For example, to explain this, I can give certain example that suppose a sample of water, suppose this is a sample of water, sample of water, it is heated up, it is heated up. Suppose the temperature of this water 298 degree K, it is raised to temperature 333 K. So what is the change in temperature? Suppose change in temperature or change in temperature, you can change in temperature delta T, change in temperature, that is equal to T final minus T initial. Initial temperature, final temperature minus initial temperature, initial. So that is 333 minus 298. This will come out to be 35 K. So this change in temperature is 35 K. It depends upon the only the initial value and final value. It does not depend upon the manner in which the water is heated. It does not depend upon, it does not depend upon the manner in which the water is heated up. The water is heated up. So only initial and final values. So I can give other examples of state function also. What are the other examples? The other examples of state functions are temperature, volume, internal energy, volume, internal energy, internal energy, E, enthalpy, H. Later I will define this enthalpy, entropy, S, and free energy. Another term is free energy, G. So these are the state function or state variables, because these properties depends upon the initial and final property, initial and final value of the property. So remember, other properties are there which are not state function. It depends upon path, manner in which it is brought. For example, or heat and work. It is not state function. It is not state function. Because its value, change in its value doesn't depend upon the initial and final value, or depends upon other factors also. Now we'll know what is the characteristic properties of state function. So characteristic properties of state function. What are the properties? The value of the state function only depends, number one, the value of state function depends on initial and its initial and final value only. Secondly, its value is independent of the path followed. Its value is independent of path followed. Thirdly, they have exact differentials. What is this? So you can write in calculus method. You can know here. Integration E1 to lower limit E2 dE. If you integrate it, it will be E2 minus E1. That is equal to delta E. Similarly, another E is the internal energy. Similarly, H enthalpy. We can integrate from H1 to H2 dH. This becomes H2 minus H1. That is equal to delta H. Change in enthalpy. It means change in entropy. So this is S1 to entropy S1, initial value S2 ds, S2 minus S1. That is equal to delta S. Change in entropy. So they are complete. They have the complete. They have the exact differential. You can write this manner. So another thing, number 4, we cannot define. We cannot determine the absolute value of state function. As well, we can only only determine the change in the values of state function. Change in value of a state function. So these are the characteristic properties. Then next thing we'll know, that is your thermodynamic equilibrium. Another thing, your thermodynamic equilibrium. Thermodynamic equilibrium. What is thermodynamic equilibrium? Thermodynamic equilibrium. A system is said to be in equilibrium. A system is said to be in equilibrium if its state variables, if its state variables or state function do not change with time and space. With time and space, you can change. Then the system is said to be in system is said to be in thermodynamic equilibrium. So what are the different types of equilibrium of thermodynamic equilibrium? There are different types. One is your thermal equilibrium. Number two, mechanical equilibrium. Number three, chemical equilibrium. We are more concerned with this chemical equilibrium. So what is thermal equilibrium? A system is said to be in thermal equilibrium. A system is said to be in thermal equilibrium if the temperature is uniform throughout all the parts of the system, throughout all the parts of the system and its surroundings. You know, surroundings, system and surroundings. Then next one is a mechanical equilibrium. Mechanical equilibrium. What is this? A system is said to be in mechanical equilibrium. A system is said to be in mechanical equilibrium if no mechanical work if no mechanical work done by one part of the system done by one part of the system on the other part of the system other part of the system this means the mechanical properties is uniform properties are uniform throughout the system then your chemical equilibrium. This much will start this next part in your next class. Thank you.